I think what you just signed is fairly self-explanatory. We know ourselves. We know the difference between right and wrong and what we should be doing and what we should not be doing. Please take care of your responsibility, your ethical responsibility. I always go with the saying or the test between right and wrong. Do not take these apart. I'll explain them in a minute. The test between right and wrong. If the act that you're doing, you're okay with it going and being put in the front page as headlines of the Dalton Gazette or the Daily Record. If you're okay with that, you should be okay. If you have second thoughts that you're squeamish about whatever act you're doing in life, no matter just this or in life, you're squeamish about that being in the headlines, maybe you should think second about doing it again or doing it. That relates directly to this also. If you're okay, yeah, me and so-and-so got together, we did this test together, and we both got A's on that test. If you're okay with that being on the headlines of the Daily or the Gazette down there, go ahead and do it. I don't think any of us would be okay with that. So once again, and that's a test in life as you go along through life. If you're not okay with it being the headlines, then maybe you should think second about doing it. Now, that being said, I think all of you will make good decisions and make good choices. I'm not trying to call anybody out in regards to that. Just if there's ever any little thought that goes into your mind, basically, you signing this is giving me your word that gets thrown onto you. I have no way of being able to prove or disprove anything as occurring. No way. That's for you to be able to deal with. So, I'm not going to go and sit there and not be, and you'll have schools like this and colleges like this that you'll have to take a test, and you'll have to have the camera on you. The camera will be on you as you are taking the test, and somebody's there watching you, and they'll be able to also see your screen. So if you're Google searching something, not that that's ever been done, they can see that you're Google searching it. So that's, I'm not going to that extreme. I'm going to, this is on you, not on me. All right, questions about that? Thank you. This is also worth 2 points to a quiz score. You get 2 preview points for doing this. Yay! Second thing I handed you was a packet of work. Okay, this packet of work is work for you. You do not have to worry about printing it from your computer at home, using your ink. This is schoolwork. So I came in and I printed everything off yesterday. So you have the next 2 weeks worth or 3 weeks worth of work right here, outside of tests. So I'm not going to absorb all your ink, which is expensive, or maybe your printer is not working. Okay? When it comes to a test, yes, I'm not going to give you that here in this packet. If you have issues with the test, what I suggest you do, or printing a test off, and some of you have already done this, take your notebook paper at home, and just copy the problem down and do the problem on notebook paper, and then you can take either pictures of that and submit it through your pictures through Google Classroom, or if you have an iPhone, in your notes section, I think, or in your picture section, you can scan. You can do a scan feature in your notes section now. That will scan it, so it just comes as one document to me rather than 5 different pictures. Okay, which is a little bit easier. I don't have to print off 5 different things. I can just print off one and everything comes. So if you have an iPhone, if you go to notes on your iPhone, it's buried underneath everything now. Somebody showed me this last year and I went, okay, if you go to notes And I'm thinking, if you go to the new notes at the bottom, if you go to your new notes at the bottom, there is a camera there. And if you hit the camera, it says scan a document or scan documents. Okay, so you're doing the new notes at the bottom. You go to notes. Now my camera pops up. If you go to camera, if you go to the little empty box with a check mark at the bottom, you hit that, a camera will appear, and you can just hit that and hit scan your documents, and you can just scan documents, and it will come to me as just as one document at that point. If you don't have an iPhone, I'm not sure. I'm just happy I figured this out. Okay. I'm happy I figured out how to Google Meet. We're on Google Meet right now, by the way. Google Meet and screencastify Google Meet for me to present on Google Meet and then screencastify, which will capture it, and then I can post it. Okay, I've graduated from iPad and YouTube to Google Meet, present, screencastify, and get it there. As I've always said in the past, there's more than one way to skin the proverbial cat. I've learned a new way of skinning the cat today, or yesterday. So even though we had a snow day yesterday, I'd rather have been here. It was still productive on my end. Once again, all the homework and all the worksheets here should be here in order. So if you want to just put this in a 3-ring binder and put it in this order, that is fine. They should be in order as I go along here. I will post solutions. I didn't put solutions there. I will post the solutions I typically do. Questions you have about that? I will try to make this as easy and seamless as possible, but this is a College Credit Plus class. We still have material we have to cover. We're going to cover it. Okay, we will cover the material. Sometimes we will have class on Fridays. I know we are only Monday, Wednesdays for a 2 hour, hour and 45 minute, or hour and a half block in there, hour and 20 minute, about whatever it is. Sometimes I will have a class meet on Friday. Sometimes I may give you work to do on Friday. Okay, it may not be a Google Meet day on Friday, but I may give you classwork to do on Friday still. Okay, so don't think Friday's a day off. Okay, Friday's not a day off. It's just I may or may not Google Meet. When we go to Google Meet, please, I'll have to take attendance, and the first thing, so you'll see my smile. That's the only time you'll see my smiling face. Okay, is when we do attendance at the beginning. You can show your face. Please turn off your mic then. Turn off your mic. Turn off the video or camera, because I don't want you guys just making faces at each other and holding up signs how much of an idiot Mr. Gregory is, and he's an idiot. Why is he making us do this stuff? Okay, I don't need signs being shown between you guys. All right, so turn your camera off, turn your mic off. I don't want to know if Rover needs to go outside. Okay, I don't need to know he's barking, he's yapping. Okay, I don't need that. Okay, if Kitty Cat, Felix the cat comes up on your lap and starts meowing, I don't want to hear what Felix the cat has to say. Questions? We will make it through this as we make it through everything. All right, for today, you had homework dealt with the trig functions. Am I correct? Trig functions. And on page 196. Page 196. As you do problems 1 to 23, the weird ones, some of them were just proving the things that we did in class. You had to use product rule, you had to use quotient rules. Questions you have about any of those? You had all the answers with Bob in the back of the book, which you probably did notice also, which you may came down to a solution. They may have simplified one extra step. Don't have to deal with that except for when you're dealing with a quotient rule and possibly being able to cancel out top and bottom, simplifying it down. You don't have to worry about factoring out the greatest common factor and leaving it at that form then. Leaving it standalone would be fine. Things you need me to go through. Alrighty, today we're going to deal with the chain rule. We're going to deal with the chain rule. The chain rule. If I had the function f of x equals x squared, or x minus 4 quantity squared, and I want to find the derivative of this. Okay, well, the one thing we could do to find the derivative would to multiply x minus 4 times x minus 4 to give us x squared minus 8x plus 16. Okay, I can multiply that out, then find my derivative, which would be what, Ozzy?
1 minus 4.
What would be the derivative of this using our exponent rule?
2x minus 8.
2x minus 8. We found our derivative. And that's fine. That's fine. We could do it that way. But the problem we run into is, what if I had f of x is equal to x minus 4 to the 5th power? Now what we would have to do is take x minus 4 times x minus 4 times x minus 4 times x minus 4 times x minus 4, which is doable. These two would give us x squared minus 8x plus 16. These two would give me x squared minus 8x plus 16. I would still have an x minus 4 there, but then I'd have to multiply all that out, which is, once again, doable, very doable, but a lot of work. So that's where we came up with what is called the chain rule. The chain rule allows us to take the derivative of a function to an exponent. A binomial, trinomial, it doesn't matter what it is. A polynomial to an exponent. When dealing with some function, f of x is equal to g of x to the nth power. And that's what we have here. We have g of x, which is x minus 4 to the nth power. We can take our derivative, first off, by doing what we did with our exponent. What we did initially with our exponent. What Ozzy did here, he took the 2 and moved it out front and dropped our exponent by 1. So we could take our n, move it out front, and go n minus 1. Okay, we're following the same method of madness. Nothing has changed here. But what we have to do now, and this is where the chain comes in, is we have to link this through multiplication. So we're going to multiply by g prime of x. So we're taking the exponent, moving it out front, and dropping our exponent. Now, keep in mind, we did nothing with the g of x. We did nothing with that. And we just left alone. We only dealt with the exponent. Once we dealt with the exponent, then we went inside and dealt with the derivative of what's inside. So if we take a look at our problem up here, we can take our 2 and move it out front. 2 times the x minus 4 to the first power times the derivative of what's inside, which is a value of 1. So distributing this through, we get our 2x minus 8. And the 1 we don't worry about because we're multiplying by 1. So if we have a function, x minus 4, 1 to the third power. We first start out by taking our exponent out front. So we have the 3, and the x minus 4 we just leave alone, and we subtract 1 from our exponent. And then we go inside our function and take the derivative of the x minus 4, which is just a value of 1. So we're left with 3x minus 4 squared. And once again, we don't have to go and expand this any further. We can leave it stand alone. We get 4x cubed minus 5 all to the 7th power. Go ahead and take your derivative using your chain rule. I just want to make sure it got to you. Yep. Take your exponent, move it out front, drop your exponent by 1, then multiply it by, and when we say multiply by, that's what the chain comes from. It's another link in the derivative. We'd link it to that. So Nate, dealing with our exponent first, what do you have?
We have 7 times the quantity of 4x cubed minus 5 to the 6th power.
Okay, then we go inside and take the derivative of what's inside, which is what?
12x squared.
12x squared. Now what we can do is we can simplify these two together. We can simplify the 7 and the 12x to give us 84x squared, and 4x cubed minus 5 to the 6th power. So if you have terms that are being multiplied together, you can simplify those together. But don't need to go any further than that. Now, a common mistake here when dealing with this, the common mistake is you bring the 7 out front, then you go inside and you take the derivative of inside, which is 12x squared, and you throw the 12x squared here, so then it turns into 7 times 12x squared to the 6th power. That's a common mistake. What you should try to remember to do when you're dealing with derivatives, you can only use one derivative rule at a time when dealing with a chain rule. Okay, so I deal with my exponent first. I don't deal with what's inside of that. Then I go inside and take the derivative of the function. And we chain that together once again by the use of multiplication. When we have a trig function, okay, we have the sine of g of x. We follow the same method of madness. Now, when dealing with orders of operations in a set of parentheses, it was always you work inside out. You work inside the parentheses first and then work yourself on the outside and you eliminate the inside parentheses. Go inner to outer. When you're dealing with derivatives, you go from outer to inner. Like my outer here was the exponent. That's my outer. And then I went into the inner. The same thing here, we look at the trig function. We take the derivative of the trig function first. So if I take the derivative of our trig function here, this would give me the cosine of g of x. Okay, just the cosine of g of x. We're just working about the outside function first. And then we chain this to, once again, the derivative of what we're taking the trig function of. So we work ourselves outer to inner. So if I'm looking at cosine of 9x squared, we first take a look at the derivative of cosine. Derivative of cosine is what, Adam?
Negative sign.
Negative sine. So we have the negative sine of 9x squared. Okay, I don't worry about what's inside the function or inside the trig function first. I just take the derivative, adjust the trig function, leave everything else alone. Now what we do is we chain that to the derivative of the 9x squared, which is what, Bailey? What? I'm sorry, what did you say? The derivative of 9x squared? Exponent rule? Take the exponent, multiply by the coefficient. So we have 18x. Now, the confusing part to this is this chain, this 18x is not associated with this 9x squared anymore. Okay, so I don't take the 18x times the 9x squared. We are just taking the sine of the 9x squared and that's it. The 18x is the residual on the outside. So how this typically is written is negative 18x, taking the negative thrown down here, times the sine of 9x squared. So whenever we take the derivative of, we sort of throw it as a coefficient to the trig function. Well, what happens when we throw an exponent to the trig function? What it does is it adds another link to this. What I've found easiest to do when I have an exponent here to the trig function is rewrite it. This is a sine of 7x all to the 5th power. That's just by definition and nomenclature of our trig function. If I have sine squared of x, that means it's sine of x all squared. What this allows us to do is gives us a good visual of working ourselves outside in with our derivatives. Okay, our first thing that we run into on the outside is an exponent of 5. So how do I deal with the exponent of 5? Well, what do we do up top here? Okay, what I do when I had an exponent, I took it out front and I kept everything else the same. So that's the same method of madness I'm going to follow here. I'm going to bring my exponent out front and drop my exponent by 1. So go ahead. Bring your exponent out front, drop your exponent by 1. Now we start chaining these. Put another link to that. Now we go inside. Well, the first thing we run into when we go inside is a trig function, sine. So I take the derivative of sine. The sine of 7x, if I just had the sine of 7x, how do I find the derivative of sine of 7x? Well, what I do here, I took the derivative of this, and then I went inside the trig function. So the derivative of sine, I have it as what? Cosine. So we have times the cosine of the 7x again. Okay, I'm just taking the derivative of sine to give us cosine. Then we have to go inside the trig function. We have the derivative of 7x. Which is what, Ozzy? Woo. A value of 7. So rewriting this, I can drop, oh, that shouldn't be a 5. What the heck happened? Oh, darn it. I tagged it down there. So now we can combine these things together. I got a 5 and a 7 I can combine to give us 35. I have a sine to the 4th of 7x times the cosine of 7x. The granddaddy of them all. Rewriting this. This is the sine of 5x squared plus 3 to the 7th, all to the 3rd power. Once again, we want to work ourselves outside to in. So you take your 3 out front, drop your exponent by 1. Then we go inside. The first thing we run into inside is a cosine. I'm sorry, a sine. So we take the derivative of sine and tag everything else along. Then we go inside, we have the cosine of 5x squared plus 3 all to the 7. Then we go inside the trig function. We have a 5x squared plus 3 to the 7. I need to take the derivative of that. So my exponent comes out front. So I have 7 times 5x squared plus 3 to the 6. And then my last link, I go my derivative of 5x squared plus 3, which is times 10x. A lot of links to the chain on this one. Once again, it's the granddaddy of them all. It's like the Rose Bowl. The things that we can combine, we have a 3 on the outside, we have a 7 on the outside, and we have a 10x on the outside. So we have 3 times 7, 21, times 10, 210 x. If I want to, I can bring the 5x squared plus 3 to the 6 out front. And then we have the sine squared of 5x squared plus 3 to the 7th times the cosine of 5x squared plus 3 to the 7th. A lot of links to the chain. We have e to the x or e to the gx power. We have a function to the e function. This one's a little bit easier. The derivative of e to the x is just what? E to the x. So the derivative of e to the g to the x is, we start out with e to the g to the x or gx power. So we have e to the gx. We just recopy like e to the x is e to the x. But then we have to take, multiply by the derivative of the exponent. Once again, just a link in the chain. So if I have e to the 7x minus 4 power, I want to take the derivative. I first off just recopy. So you just rewrite it, e to the 7x minus 4 power, times the derivative of the exponent. Now, that's not a part of the exponent, it's a link in multiplication. So e to 7x minus 4 power, so we just have a value of 7. So we have 7e to the 7x minus 4 power. Now we start having some fun. Because now we have two polynomials being multiplied together. If we have two multiplied together, we have to use our product rule. So we have the derivative of the first times the second plus the first times the derivative. Oh yeah, and now it starts getting fun. You're probably the most photogenic guy around here, Ozzy.
They would like to dress, so.
I would suggest you come down here and start it down below, because it'll take a little bit more room. So we take the derivative of the first and multiply it by the second. So to take the derivative of the first, we have to use our chain rule. Drop our exponent out front, drop the exponent by 1, multiply by the derivative inside. So we have 4, comes out front, 2x minus 3 cubed, times the derivative of 2x minus 3, which is 2x. That's the derivative of our first term times our second. So we have 7x minus 2 cubed. Plus the first, 2x minus 3 to the fourth, times the derivative of the second term. So now I have to use my chain rule for the second term. All kinds of giggles and fun here. So we have 3 that comes out front, 7x minus 2 squared, times the derivative of inside, which is a value of 7. Wasn't my better side. Now we need to combine anything we can combine. You can't combine through addition here, but you can combine these terms through multiplication to give us 8x, 2x minus 3 cubed, 7x minus 2 cubed. Plus we can combine the 3 and the 7 together. Oh, I think I botched this up, didn't I? That should just be a 2. My bad. So that should just be an 8 out front.
Thank you, guys.
Yep. My bad, sorry about that. And then we combine the 3 and 7 together to give us 21. 2x minus 3 to the fourth, 7x minus 2 squared. Division. So we have to use our quotient rule. Now, it's the exact same term, so it's going to look like the same on top, but it's subtraction. So it's gonna give us the exact same thing. 8 times 2x minus 3 cubed, 7x minus 2 cubed, plus 21. I'm sorry, that should be a minus there. Minus 21, 2x minus 3 to the fourth, 3, or 7x. Seven x minus 2 squared. So it's going to look the same, except for a subtraction there. But what changes here is the bottom has to get squared. So rather than being to the third power, we have to square that. So it's going to take it to the sixth power. To the sixth power. Now the one thing that we have to worry about now is we can look to simplify. I have 6 7x minus 2's here. I have 3 of them here, and I have 2 of them over here. So I can cancel 2 out here. This reduces to 1, and this would reduce down to 4 then. Just taking the 7x minus 2, 2 of them out of each of them. So we have 8, 2x minus 3 cubed, 7x minus 2 minus 21 times 2x minus 3 to the fourth. And this is all over 7x minus 2 to the fourth power. Very quickly, the tangent of 8x squared. Take the derivative tangent. That gives us secant squared. Derivative tangent is secant squared. 8x squared times the derivative of what's in time, 16x. Your homework is page 204. Three to 51 multiples of 3. If you have questions about homework, you need to email them. I will use them as examples the next day, the next class period. Once again, be prepared to, if we have to have class on Friday, we'll have classes on Friday, just to make sure we get through what we need to get through. We're dealing with a pretty good pace right now, but I'd like to be able to keep up with that pace. That's better on the back end when we prep for a final in this class. So that's my goal. Questions? Once again, please check in every morning. We're supposed to have class Monday, Wednesdays. We'll cover material. I'll answer any questions. We'll go over new material. For Google Meet, it's present mode, it's screencastify mode, so everything is captured through our Google Meet. Adios. See you guys on the other side of this.